This lesson, we are going to learn about the converse of the Pythagorean theorem and how to apply that. To begin, we first need to go back and look at some old vocab. The one vocab that we talked about in the past was an acute triangle. An acute triangle is a triangle with 3 acute angles. And an acute angle, remember, is an angle that is less than 90. The second vocab is an obtuse triangle. An obtuse triangle has 1 obtuse angle, and no triangle can have more than 1 obtuse angle. And then we have the theorem 7.2, the converse of the Pythagorean theorem. So we learned previously that the Pythagorean theorem is a squared plus b squared equals c squared. Now, the converse, though, says that if the longest side of the triangle is equal to the sum of the squares of the other 2 sides, then we have a right triangle. And how to also we can look at this is that if you have a triangle ABC and it satisfies the equation a squared plus b squared equals c squared, then you know that you have a right triangle. So this theorem, you can think of it as being flipped around from the actual Pythagorean theorem itself, because this is what we call the converse. Now, to put this to use, let's look at example 1. It says, tell whether the given triangle is a right triangle. So it's asking for a yes, it's a right triangle, or no, it's not. Well, for part A here, for this to be a right triangle, the C value would have to be the 26 because that's the longest side. So if I set up my Pythagorean theorem, I would take the 2 shorter sides, so that'd be 14 squared plus 22 squared, and I'm going to see if that equals 26 squared. Now if I do my math, 14 squared plus 22 squared, that's 680. 26 squared, that's 676. So these are not equal. Well, since they're not equal, that means then that this is not a right triangle. Now let's look at example B. The 3 squared 34, it'd be helpful to know what this is approximately as a decimal. In this case, if you put this into your calculator, you'll get 17.49. So the longest length would be the 3 squared 34. So I'm going to call that my C value. So if I take my 2 shorter sides, if I take 9 squared plus 15 squared, and I'm going to see if it equals 3 square root 34 squared. On the left side, 9 squared plus 15 squared, that's 306. To square the 3 squared 34, I square the 3, that's 9, and multiply that by squaring the square root, that cancels, that's 34. And I get 306 on the left still, and 9 times 34 is also 306. So since the equation comes out to be the same value on both sides, I then know that yes, this is a right triangle. Looking at example 2 now, tell whether the right triangle with the given side lengths is a right triangle. So once again, it's a yes or no question. Well, I need to know what 4 squared 3 is, and I typed this into my calculator. That's approximately 6.9. So my longest length is the 8, so that would be my hypotenuse if this is a right triangle. Once again, I'm going to set up my Pythagorean theorem to see if it satisfies. So I have 4 square root 3 squared, and that should be see if we're equal to 8 squared. So on the left side, 4 squared 16. And then if I bring the squared in, that's 16 times 3. 8 squared 64. Well, 16 plus 16 times 3, that's 64. So 64 equals 64. So to answer the question, the answer is yes. It is a right triangle. Now for part B, the longest length here is 14, so that would be my hypotenuse if this is a right triangle. So setting up my equation, I'm going to take my 2 longer sides, my shorter sides, 10 squared plus 11 squared, and see if that equals 14 squared. Well, 10 squared plus 11 squared is 221. 14 squared is 196. So in this particular example, the answer is it's not a right triangle because it does not satisfy the Pythagorean theorem. This next theorem is the Pythagorean inequality for acute triangles. It states if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. So to look at this a little bit more closely as a visual, if I have a triangle ABC, so I have lengths A, length B, and length C, if C squared is less than A squared plus B squared, and C squared is the longest length, then the triangle is an acute triangle. The next theorem is called the Pythagorean inequality, and this is for obtuse triangles. Very similar to 7.3 theorem. Again, if the longest side of the triangle is greater than the sum of the squares of the other two sides, then the triangle is called an obtuse triangle. Again, for a visual, if I have a triangle ABC, if the longest side is greater than the other two sides squared, then we have an obtuse triangle. Now let's take a look at example 3. We need to classify the triangles as right, acute, or obtuse. So to do this, we are going to set up an inequality and decide if my longest side is less than or greater than or equal to the other two sides squared. So my longest side in this example A would be the 6.1. So I'm going to call that my C value. If I set up my inequality, I'm going to have 6.1 squared, and I'm going to question, is that less than, greater than, or equal to 4.3 squared plus 5.2 squared. Calculating 6.1 squared, that's 37.21. And on the right side, I have 4.3 squared plus 5.2 squared, which is 45.53. Now, comparing it again, we're going to be comparing, is it less than, greater than, or equal to? Well, 37 is less than 45. So since that C squared value is less than, then I know that my triangle is acute. If it was greater than, it'd be an obtuse. If it was equal to, it would be a right triangle. So to answer the question is a right, acute, or obtuse. In this part A, the answer is acute. Looking at the next problem, I have the length of 12, 10, and then square root 13. So it'd be good to know what square root 13 is a decimal. Well, that's approximately 3.6. So my longest side is the 12. I'm going to call that my C value then. So setting up my inequality, I'm going to have 12 squared, and I'm going to figure out, is that less than, greater than, or equal to 10 squared plus the square root of 13 squared. 12 squared is 144. And on the other side, 10 squared is 100. The square root of 13 squared is 13. So that gives me a total of 113. Now, I know that 144 is greater than 113. So since my C squared is greater, then I know my triangle is obtuse. And then that answers my question. The question was, is it right, acute, or obtuse? And the answer is obtuse. For this last example, it says that Miss H is framing a room in her basement. She has her trusty sidekick, Miss R, helping her put in an 8-foot-high wall. So in this picture, my wall would be my vertical side of my triangle that I'm creating. So I'm going to label that as 8 feet. And I'm going to label as my wall side. Then it states that the framed wall must be perpendicular to the floor. Now, perpendicular to the floor meaning that the angle created with the green highlighted side and this yellow highlighted side must be 90 degrees. It says that Miss H has a 17-foot string and attaches it to the very top of the wall. Miss R holds the end of the string along a tape measure on the ground that's 14 feet. So the ground length here is 14 feet. I'm going to label that in my picture as well. And this is the ground side. And I'm going to go back to that previous sentence. It said that it's a 17-foot string and it's attached to the very top of the wall. And it says that Miss R holds the end of that string along a tape measure to the ground. So this distance right here, that distance is the distance of the string, which is 17 feet. Now, going back to the problem, it says, while Miss H positions the top of the wall, so that means that Miss H is located at the very top of my triangle. So here's where Miss H is. I'll put H for her position. And Miss R is here holding the string, so I'll put capital R for her position. The question says, does Miss H have to move the top of the wall further away or closer to Miss R? So this angle that we're trying to figure out here, I'm going to label this angle A. If this angle A is a right angle, then I know my wall is perpendicular to the ground. If this angle is acute or obtuse, then I know the wall needs to be adjusted. So to figure out what that angle is, I'm going to then create an inequality. My longest side is 17, so I have 17 squared. I'm going to figure out, is that side greater than or less than to 8 squared plus 14 squared. If it's equal to, then I know that my wall is positioned correctly. 17 squared, that's 289. 8 squared plus 14 squared, that is a total of 260. So to answer that question, the answer of 289 is greater than 260. Well, since this angle here is greater, that means that angle is an obtuse angle. Now, since it's an obtuse angle, that means then that Miss H needs to make this angle here smaller by moving this wall closer towards Miss R. So it's an obtuse angle, therefore Miss H needs to make the angle smaller by moving the top of the wall closer to Miss R. And that answers the question.